Hello everyone. Today we are going to start a new chapter number 1, numbers. So let's look at some of the important topics that we are going to learn in this chapter. So let's start with our first topic, large numbers. In earlier classes, we have learned about numbers from 1 to 9999. But in our daily lives, we come across different situations where we need large numbers. Let's see some examples. First, the cost of an LED TV is 24,000 rupees. Here, 24,000 is a 5-digit number. Second, the cost of a car is 8,64,000 rupees. Here, 8,64,000 is a 6-digit number. It is very easy to understand the large numbers if we understood the number system properly in earlier classes. Let's read about 5-digit numbers here. 5-digit numbers. We know that 9,999 is the largest 4-digit number. When we add one more to it, we get a 5-digit number, that is 10,000. It is read as 10,000. It is the smallest 5-digit number. In the place value chart, 5th place from the right is called 10,000th place, as you can see here, hence called the 10,000th place. Hence the 5-digit numbers start from 10,000 and go up to 99,999. 6-digit number. The largest 5-digit number is 99,999. When we add one more to it, we get a 6-digit number, that is 1 lakh, and read as 1 lakh. In place value chart, the 6th place from the right is called lakh, as you can see here. Hence, the 6-digit numbers start from 1 lakh and go up to 9,99,999. 7-digit number. The largest 6-digit number is 9,99,999. When we add one more to it, we get a 7-digit number, that is 10 lakh, read as 10 lakh. In the place value chart, the 7th place from the right is called 10 lakh. You can see here. Reading numbers. For the convenience of reading and writing large numbers, separate the digit of the number to group called periods. As we can see, first period, ones, has 3 places, ones, tens and hundreds. Second period, thousands, has 2 places, thousands and 10,000. Third period, lakhs, also has 2 places, lakhs and 10 lakhs. In fact, all periods except the ones period have 2 places only. While reading a number, digits in a period are read together. Look at the examples given below that will help us to read and write large numbers. The number 7,56,528 is written as 7,56,528. The number 7,56,528 is written as 7,56,528 and is read as 7,56,528. The number 34,287 is written as 34,287 and is read as 34,287. Now look at the table which represents some large numbers in the place value chart along with their representation on abacus. Some smart tips. The ones period has 3 places, 100, tens and ones. The 1000 periods has 2 places, 10,000s and thousands. The lakhs period has 2 places, 10 lakhs and lakhs. Place value and face value. Let's start a new topic, that is place value and face value. Now we are going to learn about some concepts regarding place value and face value. The place value of a digit in a given number is its value due to its place or position in the number. Place value of a digit is equal to face value of the digit into value of the place. Face value of a digit in a number is the digit itself. Place value and face value of 0 is always 0, wherever it may be. Expanded form. Now let's learn about expanded form and standard form. Expanded form means writing a number as sum of the place values of its digits. So students, here is our next example. In this example, write 659,824, that is 6,59,824 in the expanded form. So basically, we have to write this number in the expanded form. So we'll start from our first step, that is writing the place value of each and every digit of the given number. So let's start. So, starting from our right hand side, that is our last digit, that is 4. So, to find the place value, writing its face value and multiplying it with 1, we get 4. Similarly, for 2, face value into place value 28. Writing the face value of 8 is 8 and multiplying it with value of that place, that is 100, as 8 comes in hundreds column, so we get 800. Similarly, 9 into thousands, we get 9000. Then 5, then we have our next digit as 5. Face value of 5 is 5, and place value or the value of that place is 10,000. We get 50,000. And finally, our last digit is 6, and its place value is lakhs column. So multiplying it with 1 lakh, we get 6 lakh. So we have got all the place value of each and every digit in the given number. Now we will write these digits in the addition form. So writing, we will start from the biggest or with the place value of the digit in the largest place value column, that is 6 lakh, plus our next is 50,000 plus 9,000. Basically we are adding all the place value one by one in upward direction, plus after 9,000 we have 800 plus 20 plus 4. So this is our expanded form of the given number. So I hope students, now you're familiar how to find the expanded form of a given number. Comparing numbers. To find the greater or smaller number, we follow these steps. If number of digits in two numbers are different, then number with more digits is greater. If number of digits in two numbers are same, then to compare numbers, compare their digits from left to right, that is from the highest place value to ones. If the digits at a place are equal, compare the digits at the next place on the right. So students, this is our next example. In this example, let's see what we have to do. So let's read compare 22,002 and 2,299. So we are given two numbers and we have to compare the two numbers. We have to find out which one is greater and which one is smaller. So to do that, first we will write both the numbers. So let's start writing both the numbers first. And our second number is, so our first step would be to count the number of digits in both the numbers. So let's start counting the digits in our first number. So here the number of digits are 1, 2, 3, 4, 5. So I will write 5 digits. Similarly, for our second number, the number of digits are 1, 2, 3 and 4. So I will write 4 digits. So here the number of digits are greater than the number of digits in other number. So I must say here 5 is greater than 4. So we will write that this number is greater than this number. So we'll put a greater than sign to indicate that this number is greater than this number. I hope students, you are familiar how to find and you have understood how to compare the two numbers using counting their number of digits. Whenever we have a question where the number of digits are different, we can compare them by counting their number of digits. Okay then, now moving on to our next example and let's see what is new. Ordering of numbers. Numbers can either be arranged in an ascending order, that is increasing order, or in descending order, that is decreasing order. In ascending order, numbers are arranged from the smallest to the greatest, and in descending order, numbers are arranged from the greatest to the smallest. So students, we have learned what is an ascending order. Now we will arrange all the 4 numbers in ascending order. So first step is to calculate the number of digits in each and every number. So first of all, I will calculate the number of digits. In first number, there are 1, 2, 3, 4, 5. Okay. Now looking for the number of digits in my second number, 1, 2, 3, 4, 5. Here also I have 5 digits, whereas in my third number also there are 5 digits. But in my fourth number, there are only 4 digits. So I can say this is the smallest. And now I need to compare only the 3 numbers. So since we have equal number of digits, so in a previous example we have learned when the number of digits are equal, we try to compare them with their place values, that is with the greatest place value. So first of all, let's write them in a place value chart. So students, let's look at our first example. In this example, we have to arrange the numbers. There are 4 numbers in ascending order. As I have already told you, ascending order means to arrange the numbers in increasing order. So let's first try to count the number of digits in each number. So from our first number, we get number of digits is equal to 5. There are 5 digits in our first number. In our second number, there are 5 digits, and in our third number also there are 5 digits. But our fourth number has only 4 digits. So we can say our smallest number is our last number. So this will be our first number. So now we have to compare only these 3 numbers having equal number of digits. As I already told you, when the number of digits are equal, we compare the numbers using the place value chart by comparing the highest place value column. So the 3 numbers are to be placed in the given circles, and while arranging in ascending order, we have to place the equality sign that is less than. So now comparing the 3 numbers using our place value chart. So let's draw a place value chart. This is ones column, tens, hundreds, thousands, 10,000 and lakhs column. So now we will compare the 3 numbers by placing them in our place value chart. So first of all, we'll place all the digits of our first number, starting from the last, that is 6, then 7 in tens column, then 8 in hundreds column, 5 in thousands column, and 7 in 10,000s column. Now second number, and the last digit is 6. In tens column it is 8, then 7 in hundreds column, 5 and again 7. And our third number, last digit is 8. In tens column it is 6, 7, not 6, it is 5. So students, let's look at our example number 1. In this example, arrange the numbers 75,876, 75,786, 75,768 and 7,587 in ascending order. So basically we are given 4 numbers and we have to arrange all these numbers in ascending order. Ascending order means arranging the numbers in increasing order. So first of all, counting the number of digits, we can see that our fourth number has only 4 digits, whereas other 3 numbers have 5 digits. So we can say our smallest number is our fourth number. So we can place our fourth number as our first digit. Now we need to compare our rest 3 numbers, as the number of digits in all the 3 numbers are equal, that is 5. So to compare these numbers, we need to place all the digits of each and every number in place value chart. So let's look at place value chart and compare them from their biggest place value column. So here the biggest place value column is 10,000s column, and you can clearly see that in 10,000s column we have all the numbers same, so we cannot compare the values. Similarly, on moving from 10,000s to thousands column, we can see the number of digits are same, that is 5. Still, we cannot compare the numbers. Now, moving on to one next place value column, that is hundreds column, we can see that the largest value is 8. So we can say this is our largest number. So we can say this is the largest number, or we can say this is the greatest number. So greatest number will come in our last, that is 7, 5, 8, 7, 6. Now we only need to compare the rest 2 numbers. So moving on to tens column, we have 8 and 6. So 8 is greater than 6, so this number is great. So our second number is greater than the third number. So we can say our second largest number is 7, 5, 7, 8, 6, and the remaining we get 7, 5, 7, 6, 8. So in this way we have arranged all the 4 numbers in ascending order. Successor and predecessor of a number. Successor of a number. The successor of a number is 1 more than the number. So we have to add 1 to the number to get its successor. For example, successor of 4,57,126 is 4,57,126 plus 1, which is equal to 4,57,127. Similarly, successor of 14,576 is 14,576 plus 1, which is equal to 14,577. Predecessor of a number. The predecessor of a number is 1 less than the number. So we have to subtract 1 from the number to get its predecessor. For example, predecessor of 50,640 is 50,640 minus 1, which is equal to 50,639. Predecessor of 10,000 is 10,000 minus 1, which is equal to 9,999. Forming numbers. To form the smallest number, we arrange the given digits in ascending order. To form the greatest number, we arrange the given digits in descending order. While forming the smallest number, if 0 is among the digits, it is placed at the second place after the smallest digit. So students, let's look at our first example. So let's form the greatest and the smallest 5-digit numbers using the digits 2, 4, 0, 9 and 5. So using these 5 digits, we have to form a greatest 5-digit number and a smallest 5-digit number. So first of all, we will form a greatest number. So to form the greatest number, what we need to do, we need to arrange the numbers in the increasing towards decreasing order from the left hand side. That is, the greatest digit in the greatest place value column and the smallest digit in the least place value column. So here we have greatest digit, that is 9. So from our left hand side, we place the greatest digit first. So our first digit, it is 9. Then after 9, the greatest digit is 5. Then after 5, we have 4. Then 2. And at last it is 0. So this is our greatest 5-digit number. So now moving on to our smallest. So to form the smallest number, now we need to do what we did in the previous. So to form the smallest number, we need to do opposite of what we did in the greatest number. So in the greatest number, we place greatest digit first and moving towards the least digit. So in the smallest number, we need to place the smallest digit first. But in this case, one thing to be kept in mind that we can never keep 0 at first place, because if we keep a 0, then it becomes a 4-digit number. So except 0, which is our smallest among the 5, among the rest 4, the smallest digit is 2. Now we can place a 0. Then after the rest 4, 0. Then the rest 3, the smallest is 4. Then 5. And at last 9, which is the greatest. So this is the smallest 5-digit number. So I hope students you understood one thing to be kept in mind, that we never place a 0 at the first place because it makes our digit a 4-digit number. So except that in the second place we can place a 0. Except for the first place we can place 0 at the second place. So now we can see that the greatest number is 95,420 and our smallest 5-digit number is 20,459. So I hope students it is clear to you how to find the greatest and the smallest number using the given digits. Estimation. Palak went to a music concert and could see large number of people in the auditorium. When her parents asked how many people were there, she said maybe few thousands. Smart tip: estimation means making a fair guess about numbers. It is also called approximation. In our daily life, we come across several situations like this where we have to guess or estimate numbers to nearest 10, 100 or 1000. While you can do the approximation or estimation roughly in day-to-day situation, there are certain rules to be followed. Let's learn about these rules. rounding of number to the nearest 10. To round off a given number to the nearest 10, we find out the multiple of 10 which is nearest to the given number. For example, consider the numbers 22 and 29. Both the numbers lie between 20 and 30. Let us draw a number line and locate these numbers. As you can see, on the number line, 22 is nearer to 20, so we round off 22 to 20. On the number line, 29 is nearer to 30, so we round off 29 to 30. Thus, the rules to round a number to the nearest 10 are as follows. If the digit at ones place is less than 5, then replace the ones digit by 0 and keep the other digits same as they are. If the digit at ones place is 5 or greater than 5, then replace the ones digit by 0 and increase the tens digit by 1. So students, let's look at our next example. Example number 1. Round off each of the following numbers to the nearest 10. So in this example, we have to round off the numbers to the nearest 10. So first of all, I'll tell you how to round off the numbers to the nearest 10. So to round off the number, first we need to look the digit at the ones place. If the digit at the ones place is less than 5, then we replace the digit with a 0. That is, the digit at ones place is replaced by a 0 and rest of the number remains same if the digit at ones place is less than 5. Basically, if the digit at ones place is equal to 5 or greater than 5, then we need to replace the digit at ones place with 0, and whereas the digit at tens place increases by 1. So let's take a look at our example first. That is, we are given 47, so we need to write the round off number to the nearest 10 of 47. So as we can see, the digit at ones place is 7 and 7 is greater than 5. So what I have told you, if the number at ones place is greater than 5, so we need to replace the number at ones place with 0. So instead of 47, we will get 0, and the number at tens place increases by 1, that is 50. So our round off number is 50. So I hope you have understood how to round off the number if the digit at ones place is greater than 5. So now take a look at example number 2, that is part B of example first. Here the number is 924, but we need to look only for the digit at ones place, that is 4. So here the digit, as the digit at ones place is 4 and 4 is less than 5, so we need to replace only 4 with a 0. That is, our round off number becomes 920. So I hope you have understood how to round off a number to the nearest 10. What we need to look for is the number at ones place, like in the two examples A and B. So you have understood how to round off the number to the nearest 10. So now take a look at our next example. Rounding off numbers to the nearest 100. To round off a given number to the nearest 100, we find out multiple of 100 which is nearest to the given number. For example, consider the numbers 723 and 779. Both the numbers lie between 700 and 800. Let us draw a number line to locate these numbers. As you can see here, on the number line, 723 is nearer to 700. So we round off 723 to 700. On the number line, 779 is nearer to 800. So we round off 779 to 800. Thus, the rules for rounding off a number to the nearest 100 are as follows. If the digit at tens place is less than 5, replace ones and tens digit by 0 and keep the other digits as they are. If the digit at tens place is 5 or greater than 5, increase the hundreds digit by 1 and replace the tens and ones digit by 0. So, the rounding of the number to the nearest 100 involves two major points. First, if the number at tens place is less than 5. So, if the number at tens place is less than 5, then we need to replace the number at tens and ones place with 0 and rest of the numbers remains the same. So, let's look at example from first. So in this example, we are given 1923. As you can see, the number at tens place is 2 and 2 is less than 5. So replace the number at tens and ones place with 0. So what we get, we replace the digits at tens and ones with 0. So what we need to do, we only need to replace the number at the digit at tens and ones place with 0 in case the number at tens place, that is 2, is less than 5. So our round off number becomes 1900. So this is a round off number to the given number. So I hope students you have understood how to round off the number to the nearest 100. First thing, count the digits. First thing, look for the digit at a tens place. If it is less than 5, then replace the tens as well as ones digit with 0. Rounding numbers to the nearest 1000. To round off a given number to the nearest 1000, we find out the multiple of 1000 which is nearest to the given number. For example, consider the numbers 8250 and 8750. Both the numbers lie between 8000 and 9000. Let us draw a number line and locate these numbers. On the number line, 8250 is nearer to 8000. So we round off 8250 to 8000. On the number line, 8750 is nearer to 9000. Thus, the rules for rounding off a number to the nearest 1000 are as follows. If the digit at hundreds place is less than 5, replace the digits at hundreds, tens and ones place by 0 and keep all the other digits as they are. If the digit at hundreds place is 5 or greater than 5, increase the digit at thousands place by 1 and replace the digits at hundreds, tens and ones place by 0. So students, now look at our first example. So in this example, round off each of the following numbers to the nearest 1000. So now we have to round off the given number to the nearest 1000. So to round off the number to the nearest 1000, we need to look for the digit at the hundreds place. So if the digit at hundreds place is less than 5, then we need to replace the digit at hundreds place, tens place and ones place with 0. So now start with our first example, that is A part 7487. So in this we have the digit at hundreds place is 4, and so the digit at hundreds place is 4 and 4 is less than 5. So since 4 is less than 5, then we need to replace the digit at hundreds, tens and ones place by 0. So our round off number becomes 7, then the digit at hundreds place replaced by 0 and tens place and ones place also with a 0. So our round off number is 7000. Roman numerals. Numerals are used to represent numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 are Hindu-Arabic numerals. Roman numerals is other system of writing numbers. It has 7 basic symbols, that is I for 1, V for 5, X for 10, L for 50, C for 100, D for 500, M for 1000. It has no place value system and it has no symbol for 0. We have learnt reading and writing Roman numerals up to 20 in the previous class. Let us extend the system to read and write up to 100. Rules for forming Roman numerals. Rule 1. Repetition of a Roman numeral means addition. For example, here there are 3x, x, 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 which is equal to 10 plus 10 plus 10, as x denotes 10, which is equal to 30. So 3i's is equal to 1 plus 1 plus 1 equals to 3. Now 2x, x, x is equal to 10 plus 10 equals to 20. Rule 2. A smaller numeral written to the right of a larger numeral is always added to the larger numeral. For example, xii is equal to 10 plus 1 plus 1, which is equal to 12. Similarly, xv is equal to 10 plus 5 equals to 15. Lx is equal to 50 plus 10 equals to 60. Rule 3. A smaller numeral written to the left of a larger numeral is always subtracted from the larger numeral. For example, Ix is equal to 10 minus 1 equals to 9. Xl is equal to 50 minus 10 equals to 40. Xc is equal to 100 minus 10 equals to 90. Rule 4. When a smaller numeral is placed between two larger numerals, then it is always subtracted from the larger numeral immediately following it. For example, xxiv is equal to 10 plus 10 plus 5 minus 1 in brackets equals to 24. Xix is equal to 10 plus in brackets 10 minus 1 is equal to 10 plus 9. 10 plus 9 equals to 19. Smart tip: only I, X, C, M can be repeated. B, L and D cannot be repeated and cannot be subtracted. No symbol can be repeated more than 3 times. X can be subtracted from L and C only. C can be subtracted from D and M only.